This is the support session for assignment 2 for SMAA. I'm going to walk you through the assignment and discuss what is expected and how to approach it. Okay, so let's begin. I'm going to share my screen. All right, okay. So I won't go over question 1. It's purely theoretical, and I don't think it's unfamiliar to you. Okay, so you should be fine for that. Question 2, you're assessed on logistic regression. So how to go about, let me just share an alternative data set so I can just walk you through what the question is all about. Okay, so you need to create a model, specifically a logistic regression model, to predict your y, okay, given a certain variable x. In the example that I'm showing you on the right, what I have here is your x variable is your income. Say it's in 10,000. So the first person, the salary is 1.8 times 10,000. That's their salary. The next person is 1.89 times 10,000. But you don't have to worry about the 10,000. It's just the values in A that you actually need to be focused on. So you're going to use the values for your X or in your A column to predict your Y variable. Now in my example, my Y variable is whether they will purchase a product. So 0 means they won't purchase it, and 1 means they will purchase a product. Okay, so I'm going to use income to predict that, okay, to predict whether it's a 0 or a 1. So what you need to do is you're essentially creating a linear model, right? So your first step is to create a equation beta naught plus beta 1 times x. Now your beta naught and beta 1 is something that you can just set to whatever value you want, right? Initially. So you need to initialize it. So as you see here, what I've done is I just created some values, all right? What values it is, it's not too important. You can use your discretion because you're going to change this, okay? And you should come to the same values in the end, no matter what values you initialize it to. Okay, so there's my beta naught, my beta 1, all right? As I'm showing in my equation on the left. So this equation, let's say it's equal to L, all right? We'll call this L. This is actually your logit function, all right? So what I'm doing here, this beta naught plus beta 1 times x, that is my column C. So this is my L, all right? And all I'm doing is I'm plugging in all my x values, that is your A values, into this equation, right? Now you know what your beta 1 is and your beta naught because you set it here. So all you got to do is compute that, all right? So if you look at my logic calculation, you see it takes into account beta naught plus beta 1 times your x value, all right, your column A. And that value is what you find in column C. And you would do the same thing for every row, okay? You keep your beta naught and beta 1 fixed, and the only thing that should be varying is your x value, all right? So you'll have your logit values in column C, all right? So this is your column C, all right? Now you can follow my guideline or you can do it your own way. It's really up to you, but this is just one way to do it, okay? All right, so that's your step 1. The next, for column D, what you want to do is you're going to do another calculation. It's going to be 1 over 1 plus e to the minus L. Now the L is what you got from column C. So you're just going to feed that value into this equation here. All right, and this next equation, these are your probabilities. So this is your probability, and I'm going to make it my column D. All right, and that's what I'm pretty much doing here. All right, the E, remember, in your calculator, you'd see E in Excel, it's the function exp. Okay, so you would type E equals to exp, and that's the same thing as E. So if you say I wanted e to the minus 5, like that, in Excel, it'll be equals to exp, open brackets, minus 5. All right, that's how you did in Excel. I'd make a note of that. Okay, so that's what I'm doing here in this column. All right, so you'll do the same thing for all the rows, and now you've got all your probabilities. So what you're saying here in these probabilities is you're saying for someone who has an income of 1.8, all right, the probability of purchasing the product is 0.17. All right, okay. Lastly, in column E, okay, you're going to calculate the log likelihood. Okay, and this would have been covered with you in your session, your masterclass session, but I'll just quickly show you essentially what your log likelihood is. Remember your log likelihood, the equation for that is simply just your natural log, natural log ln of your values that you have in column D. All right, so let me just say this, the values in column D, let's just call it P, because these are your probabilities. So you're just taking the log of whatever values you have in column D, log of P. But just to be careful, right? Here, you're only going to take log of P, right? When your Y value is 1. So if you see here, I'm going to use logic to say only when my Y values, that is my values in B, only when it's in 1, then take ln of P. Otherwise, I want to take ln of 1 minus P. Otherwise, or you can say Y equals to 0. It's the same thing as saying otherwise, because Y can only take on 0 and 1. All right, it's the same thing. So if you're using an if statement, then your first condition will be this, and then this is your else. Right, so you have to use an if statement to code this logic. Okay, so if your target value is 1, then take the log of column C. Right? Otherwise, take the log of 1 minus C. And that's your log likelihood. All right. And now what you need to do is you need to take the total log likelihood, and you're going to use this to actually optimize your beta values. So essentially what your best beta values are, it's the values for beta naught and beta 1 that maximize the sum of your column E, that is the sum of your log likelihood. And you need to use solver to do that. All right, so what you're trying to say is, if you had to use solver, right, you're saying, if it pops up, there we go, it's another screen. Okay, what you're saying is, I want my total log likelihood to be maximized. So I'll click on maximize by changing my beta naught and beta 1. All right. You can untick this make unconstrained variables. All right. You don't need that. And then you'll just solve it. All right. And then that'll give you your best beta naught, beta 1 values. Okay. Now, once you've got that, now you can make predictions. Along comes a new point, someone with a salary of 3.2. Okay. You want to work out what their probability is of purchasing your product. That is, what's the probability of Y equals 1? So your step basically is just to follow what you've done here above. You've already done the work. So all you got to do is kind of just repeat the calculation for the new point. You need to get the logit, and then you need the equivalent probability value, which is using the formula that you used in column D here. That'll give you the probability. So that's saying the probability of this person with a salary of 3.2 buying the product is 24%. All right, that's how you work out the probabilities. And then what does beta 1 mean? So remember, if you look at our equation here on the left, beta 1 is the slope. All right, so the slope tells you how a change in your x variable is going to affect the change in your y variable. So in other words, in our case, if you look at our optimized beta value, beta 1, the slope, it's here. I'll just make it red so it draws your attention to it. Right? It's 0.30. So what we're saying is, as income increases, so my x variable, which is income, right? As it increases by 1 unit, then the log odds, okay, log odds of purchasing increases by 0.3, this value here. All right. Okay. Right, so that's question 2, pretty straightforward. All right. Let's move on to question 3. All right, question 3. So it's not too much. I'm not going to do the calculations here. It's left to you to actually do this. But essentially, you have precision and you have recall. All right. Now, these metrics are used for when you want to focus on false positive or false negatives. All right. And you need to figure out which metric is it precision or recall that focuses on false positives, and which one focuses on false negatives. All right. You'd have to do the calculations for recall and precision. You need to determine the formula for that. Okay, I'm not going to give that to you, but it's easily obtainable. So you want to get the formula for recall. Sorry. All right, for recall, and then you need the formula for precision. And these formulas are going to use your true negatives, your true positives. It's going to use your false positives and your false negatives. These values, which are given to you in this equation and your question paper. So I'll just go back to it. So you have some context. You see here, they give you the true positives, false negatives, etc. And they give it with 2 models. So you're going to have to work precision and recall out for both of these models. All right. And once you have those values, you can compare each model to each other. All right. So maybe neural network has a higher recall than logistic regression. And what does that mean? Okay. You need to interpret that. So coming back to here, what you also want to know is, okay, so once you've identified whether recall focuses on minimizing false positives or whether it minimizes false negatives, once you determine that, then you need to figure out when would false positives be important to minimize. You need to apply your mindset and intuition to this. So for instance, look at false positives, right? When would you want to minimize that? When does that become more important than false negatives? Think about a patient that maybe goes for scanning for breast cancer. Now, as you can imagine, if the result is positive, that can lead to quite intensive treatment and surgery. So you want to be absolutely sure that when it is a positive, it actually is a positive. So you don't really want it to be a false positive, right? So that example, you need to apply your mind to other examples as well, right? So provide examples when you want to minimize false negatives and false positives, and which metric, is it precision or recall, that you would use to determine that, right? Provide examples, right? Okay, so that's question 3. Let's move on to question 4. Okay. So here, given a linear SVM with a normal vector w equals to 2 and minus 1, compute the margin width. Right now, I understand that you haven't covered this as yet. So what I'm going to do is I'm going to explain this at a high level. So you should still be able to answer it, even though you haven't covered it as yet, but this should help you. All right, so I know this diagram on the right is quite busy, but I will explain it to you. So ignore all the writing. So I just want to check that I'm recording again. Yeah. All right. So ignore all the writing. Okay. What I want you to focus on is look at the red squares and the blue circles. Now, those shapes represent 2 different classes. Now, maybe the blue shape represents I'm sorry, the red squares represent clients that bought the product, and then the blue circles are the clients that did not buy the product. So what SVM tries to do is it tries to create these margins. And what I mean by these margins, I'm talking about these dashed black lines. These parallel dashed black lines separate the two classes. So the blue dots and the red squares. And you want the distance, the vertical distance, or not vertical, I'll say perpendicular distance between these dashed lines to be as large as possible. In other words, this green arrow. SVM tries to find these black lines, the black dashed lines, as well as maximizing the distance between them, shown by this green line. And when it can do that, then it means it can effectively predict these classes because it can separate them. That's essentially what SVM does, right? So when you're asked to work out the margin width, what you're actually asked to work out is the size of this green arrow, the length of this green arrow, okay? Now to do that, okay, there's a specific formula you would use to do that, and I'll talk you through it. And just clear my whiteboard here. Sorry. It's frozen. I'm just going to pause it until I fix this. I can't, sorry.